So hello friends, Shivansh this side, and this live stream I'm gonna show you a very interesting thing which I found in a very interesting book, which is Edward Penny's differential equation book. My mouse, this thing. And yes, let me tell you a very interesting thing kind of thing. Have you ever thought that, for example, we have a system of differential equations? First of all, what a system of differential equation means? It means basically something like this. Like we have two or more differential equations in many variables and we just want to solve it. Anything, let's say 6x plus 7y. Okay, we want to solve it for x and y. So yeah, I would agree one very great method would be, you would say that differentiate again and replace y dash as same, and then again put y from this equation, you will get what you want. I agree, very nice way, a very cute method. But what if I say I have here plus 8z, and then here also plus 9z, and then here 10z, anything, 7x plus 8y is equal to z dash. Now what? Okay, now some of you might would say differentiate it, differentiate it, put in form of z dash and eliminate all three variables, doing something. Yes, yes, but what if I want to generalize it to many variables and many things? Along with it, what if I have something like plus ft over here? Of course, one more thing which I haven't told you, and it's not very much obvious, but I think pretty obvious. Something kind of notation is that here x dash means dx by dt. Like, I know you know that prime means, but emphasize on time. That all these are function of time. No, like not time, any other variable, any variable. Okay. So this was our first motivation of this video, like of the stream. And second thing, like first of all, you must be knowing what a matrix is. X1, 2, 1. This is like anything. Matrix is a way of arranging things. Okay, so let it be like it's A. So what is the derivative of matrix means? Derivative of matrix is taking derivative of everything, every element, every row inside it. Okay, so I mean to say that let's say I have my matrix 2x, 3x, x, and let's say 1, and I define it as A, and I say what is A dash. A dash is basically 2, 3, 1, 0, and it's of course in form of dA by dx kind of thing. And I think like it's pretty much convincible. Like, I think you must be convinced that what I'm saying. But even if you're not, I have a proof for it, and this is a proof which I suddenly like just thought right now while making this video, like while telling you the thing. Let's say what does a dash at point x means? Like it's a very simple thing, nothing huge. A dash x plus h minus, like sorry, ax by h. Okay, so if I would evaluate ax plus h, like let's say it's a matrix function, so it would be 2 times x plus h, okay, minus 3 times x plus h, sorry, not minus, nothing, x plus h. I'm writing ax plus h, matrix ax plus h, and 1. Then I would do minus ax, then I will divide by h, and I can do minus ax every time and divide h same time. So I think now you must have been convinced that what I'm trying to say is correct. Okay, so this is a notation kind of thing, derivative of a matrix. One more very interesting thing is that if this is a vector in form of 1, 2, 3, this means you must be knowing I cap plus 2 j cap plus 3 j cap. It can be represented by a column vector. This is a standard way of representing a vector in form of a matrix, column vector, 1, 2, 3, I cap plus 2j cap plus 3k cap. Okay, so this is also one more thing, like representing a vector in a column matrix. But what was our second motivation? Our second motivation is that we try to solve this equation d by dt of a x, where x is a matrix, a column vector, is equals to a times x, where x is again a column vector or a column matrix or a vector kind of thing. Okay, now when it's in a simple algebra kind of thing, you would say that it's not a very difficult problem. Like dx by dt is ax, and here of course a is also a matrix or a vector, anything, a transformation of vector even. Okay, like you knowing that multiplication of matrices means like transformation of each other in rotation of x and all. So what I'm trying to say that if it is in single variable simple calculus ways, then oh, there are 6 viewers with me. Cool. So what does it means? Basically, I multiply e to the power x both sides. Oh, sorry. What am I? Just simply, I will what I'll do. I will put dt here, x below, dx by x is 80. Okay, adt, and then I would integrate both sides. I will get something like ln mod x plus c is 80. Okay, but if here, oh, just a second. But what if I'm saying, what if it's a vector or a matrix? Like, does like writing this a vector like this, does it even make sense? What I'm trying to say that dx by dt is ax. Okay, so like what the method I was trying to saying that I multiply e to the power ax both sides, then it makes sense that e to the power ax into x dash is equals to ax e to the power ax. No, it isn't giving anything. I don't know why it's tagged in my mind suddenly. Anyways, what I'm trying to say that e to the power ax is something solution kind of thing like ln x. It's ln x plus c. So you would suggest solution like x is equals to c e to the power 80 kind of thing, right? But if it's a vector, does it, or let's say it's a matrix, does it even makes sense? Like here for our consideration, matrix and vectors of course are not same thing, but represents kind of same thing. Okay, so like first of all, first step, taking a vector in denominator is even, does it make sense? Okay, so what I'm saying that shouldn't we define something like this, not in terms of vector, uh, of course. Let me see my voice is coming or not. So like first of all, first step, yes, it's coming. So e to, of course not in this form, but something in form of like we can even define this form, but I'm not in much favor because you know what, uh, we know that series of this is 1 plus x square by 2 factorial dot dot dot, है ना? if you go for a vector form, then x square makes sense, but x cube of vector doesn't make any sense. So we would think in terms of a matrix, e to the power x. Of course, x is nothing like, not like that thing, but x is a matrix, and it makes sense because it's like 1 plus x square by 2 fact plus x cube by 3 factorial, and x, like power of matrix, does make sense. So our next motivation is basically, our first motivation was to find the solution of linear equation system, like solution of system of linear equation. Our second motivation is solving this differential equation in terms of vector, or basically I would be more inclined toward matrix in this video. I would write it as like a vector, but it is matrix from my end, because in the next, like in my future consideration, I would convert this vector into a system of vectors, and hence a matrix. Okay. And third thing is making sense out of a to the power 80, where a is a matrix or it's just e to the power a. Okay, so these are our three missions, and I don't know how much time I've taken in just showing that what's our mission. Just a second. By the way, why are people going away? Is it too much boring? Anyways, so let's start the magic. So our first thing, like of course all three things are related, that's why they're in the same video. So first thing is that system of differential equations, and that too I will start with an example. For example, x dash is equals to 7x plus y, and y dash is equals to simply x plus y. And why not simplify coefficients of this as well, x plus 2y. Okay, so let us try to make sense in a way we didn't. Of course, the first way is the very simple one that you would all suggest, that take derivative both sides and you would find something, 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 something. But let's try to make sense in a way we did in linear equation topic. For example, I say you it's x plus 2y and 0 is x plus y, right? So what you would be doing, like you would say that ax is equals to b, right? A, where a is a coefficient matrix 1 2 1 1, x is something which I have to find, xy is equals to b. B is what? 70. Okay, because this thing gives this thing, right? So I am trying to make sense in similar way. I would write x dash y dash is equals to basically 1 2 1 1 into xy, and boom, this is what, like that boom. Like let's say this is x vector or x matrix precisely. So this is x dash, and ax is equals to x dash is our thing. And you won't believe, this is the second motivation, like the second thing we would do today, right? So basically what I'm trying to say, that first thing and second thing are just the similar things. Okay, now let's do it. Basically, if you see that here x dash is equals to 1 into 1211 xy and its derivative kind of thing, so you would be knowing that if we see in this form, its solution is something like, if it's in a linear form, its solution would be something c a to the power 8 c e to the power 80, right? So if we try to solution for this thing in terms of matrix, okay, can't we say it's some like, because of course e to the power matrix doesn't make sense for us right now. So won't we say something like vector into e to the power at or anything e to the power rt, right? What I'm trying to say is that, okay, so to make you convince of this thing, let us just assume something is, there is something like this. Basically I'm saying there is a vector into e to the power rt, where r is any scalar, is solution of this thing. Okay, now what's next, and what is like way I can make you convince, way I can convince you is that you plug this thing into this thing. Okay, then you will be partially convinced of my thing, because like you will get something else, but you'll kind of convinced that yes, at least you are getting something. Okay, because the real motivation of predicting it or telling that this is the solution of this differential equation is just purely intuition kind of thing, right? Like we are just guessing that this could be the good solution, or it seems to be like it's the same way it's here, right? And you can even argue with me that here it's a, here it's capital A, you why aren't you putting it here? But my argument is that as of now, until we haven't done section 3 of this video, it doesn't make sense for us, right? So this is my kind of assumption or my claim that this is kind of thing should be solution, and even I will make sure that I convince you that this is solution. But before that, we can also do one more thing, like why not just find out the solution using the ways we are discussing. Basically x dash is x plus 2y, y dash is x plus y. So what we are saying that take derivative both sides, okay, y dash plus, right, and put x dash is x plus 2y is x plus 2y plus y dash, and put x again in terms of this thing. For that we have to again extract in, like in terms of y dash and y, we find out that x is y dash minus y dash minus y, it's something we are getting, like, right? So you would see that like you can guess it something in form of, yeah, I'm lazy to do this thing, I don't want to do it. So anyways, like we are convinced that here we will get e, because at the final we will be getting a linear homogeneous equation of higher order, right? I am guessing something like this. Okay, so this is the linear homogeneous equation in higher order, and its solution is e to the power something something plus c2 e to the power something something something, right, for y, and similarly plugging in that thing we would get x. So basically biggest anything we would say accomplishment of ours is that we have converted this 2 degree to second order differential equation, not degree order, second order differential equation to one order differential equation. However, it's of matrix, but at least it's of first order and this is of second order. So we have at least accomplished something using our matrix, boys. So my assumption and my claim would be this thing, and I'm sorry that I am like I am myself convinced, or I won't be make you 100% convinced that why did I guess it. Okay, and why did I guess it? Because it seems relatable like this thing. Okay, and you would see it later that actually the solution is something like this only, at, like this scalar would also even transform to this thing. Okay, so let not beat around the bush and just get to the point. One more thing is here that I have mentioned it, like if I'm writing it as x vector, it means something like this. Okay, so let's do it. What sort of equation? Ax is equals to x dash, and using our intuitive mind we have guessed, or we are claiming that this is the solution. Okay, however, this is a very narrow field of finding solution. I would give you a broader field of telling that. So a into v e to the power rt is equals to v r e to the power rt. Okay, where e to the power rt is scalar but v is vector, so we can cancel it. Even r is scalar, and av is equals to vr, right? And here r is scalar, so of course it means I is multiplied. Like, it doesn't even matter. So even I can write I whenever I wish to, is equals to riv. I hope you're convinced this is a simple thing, right? Now what I'm doing, I'm taking it that side and I am getting it like this. 0. Okay, so basically, let me repeat what mechanism kind of thing I have predicted of solving differential equation in matrix. I'm just simply finding the single variable solution and manipulating in terms of matrices and trying to get something good, right? So this is a well-known form of characteristic equation and usually known as eigentheory's most basic equation. Basically, this is a vector and this is a transformation, and R is a scalar such that this transformation always collapses to a zero vector or null vector, right? And for that we have to find R, and finding R, like R is here a eigenvalue, and finding R is itself a, it's a easy task. So to find R, what we have to do, you have to just put this thing, this buddy as 0, right? Because it's a zero vector, then its magnitude is 0, and making sense of this magnitude doesn't seems good, but anyways, you must. Or one more way of telling is that for example, if it's not 0, then its inverse would have been existing, and if its inverse would have been existing, we could have multiplied it that side. Like, let's say a minus ri, a matrix itself x, xv is 0, right? So here if I multiply x inverse both sides, this would be 0 always, and this would give I. So that means v has to be 0, and it's not general, right? Basically, it's not in terms of vector. It's not necessary that if you apply a transformation to it, it always collapses to 0 if and only if this vector is 0. I'm repeating, it's not general, yeah, it's not always true that to collapse this vector to 0 0 using a transformation, you have to assume this vector itself to be 0. You can do some matrices, like you, sorry. You can do some transformations to make it at 0, make it as 0. For example, let's say it's 6 plus 7 plus 6 iota. Like, it's a complex number, but same thing, right? So using rotation all things only, like let's example I'm taking a transformation like this only, we are getting zero vector. However, matrix is something more vaster and farther than it. But anyways, what I'm trying to say that I have made you convinced that inverse of this should not exist for this to for to non for the vector to be non-zero, and for that a minus ri's determinant should be 0, and correspondingly we would find some r, and very interestingly, r, the value of r, like the number of r, the cardinality of the set of r is equals to order of matrix. If matrix is 2 is to 2, we will get 2r. If matrix is 3 is to 3, we will get 3r. And to prove it, like, its proof is very simple. Okay, so first of all, you have to be convinced that since determinant is like broadly, I should say, defined for normal, like square matrices. So this is a square matrix. So if it's of n order, then where I is our 1 0 0 0 1 1 1. So it's of n order, then we will get minus r term n times in diagonal matrix. So when you are computing a determinant, so this would straightforwardly give r to the power n, and using fundamental theorem of algebra, I guess. It's fundamental theorem of algebra. Number of roots equal to number of thing. So we deflected a lot. Basically, we have to find eigenvalues, right? So when we would find eigenvalues, then using this thing a minus ri, which is necessarily not null, okay, into v is 0, this would give us many conditions, many constraints on v, and that would be sufficient to make a that would be sufficient to find family of vectors, right? So actually sometimes I forget that what the hell I was doing. Yeah, so yes, now we got the solution because our solution was v e to the power rt, and v is the vector we have found using this thing. R is the eigenvalue correspondingly. But as you would know that like you won't be knowing, let me tell you it is an information that the order of differential equation is equal to number of linearly independent solution it would yield, right? So this is superficially, for our case, it's a first order differential equation. But when we saw it in the form of systems, it was multi-order differential equation. So basically, of this differential equation, superficial form, right? Basically, not in superficial form. I don't know what words I have to use for that thing. Basically, number of variables on which we are operating is equals to number of linearly independent solution we would get. Alright. Example, if we are working on two matrix, then it definitely implies that X vector is having two elements. Okay. So it on like it of course guarantees that we would having two linearly independent solution. Why? Because what is our solution? Our solution is v e to the power rt, and r itself has two values, right? I hope I'm trying to make you understand what I'm trying to say. Because this solves a very major issue, right? And at the end, I would be doing a thing which I haven't done, like I would be doing first time in my life. So please be there. So a minus ri, sorry, what am I doing? Let's start with an example. Simply 2, 1, 1 into x is equals to x dash. I think I have messed up in order, but I know you understand what I'm trying to say. So what was our solution? Yeah. So what I was saying. Oh, sorry. Yes. So basically, v e to the power rt in form we would get number of solutions, and that number would be equal to order of our square matrix, right? I have convinced you in this thing, I hope, because that was like a pretty superficial intuition based thing. So our final general solution would be c1 v1 e to the power r1 t and sigma c2 right, and sigma would go on till order n, which is order, right, for an n to n square matrix you are considering. So here we would get two solutions, and our final solution would be c1 solution 1 plus c2 solution 2, right? Hmm. Now let's do it. Write characteristic equation of it. For that I know a very beautiful trick I would like to share it with you. First way is to make it 0. Second way that I have learned expression for it is that x square minus trace of x plus determinant. This is characteristic equation for 2 into 2. For 3 into 3 I also have informed that that's pretty ridiculous, so I don't want to share it. X minus trace of a is 3x plus mod a, t minus, sorry, 2 minus 1 1. Okay, this is a characteristic equation, and its root is known as eigenvalues, eigenroots, right? Oh, it's not having very good roots. 3 plus minus root of 5 by 2. Come on, they're very bad to look upon even. Now I want a simple one. Like in the sense, operating on this is very bad. Like I don't think it's good. So let's say we take a very cute one. X is simply y, and y dash is simply x plus y. Let's say. And I don't want the quadratic equation to be as bad as that one. So our coefficient mass was this, like for this thing is this. Okay, so characteristic equation is x square, our trace is x minus, oh even worse. It's getting something in form 5, 5, 5, 5. Okay, plus root 5 only, I won't write that number. Okay, so these are my eigenvalues, right? So using my eigenvalues, I would find eigenvectors, and using my all eigenvalues, I would get many eigenvectors, and this would give us solution, right? Now this solves our first part, second part of our consideration, because if I want to find what x, like if I want to write what x is in a combined form, like as a group of vectors, then it's v1 e to the power r1t and v2 e to the power r2t, right? And here v1 itself represent a vector, so it's a group of vectors kind of thing. That was the thing I was trying to say, telling you. Now let's say I have this thing, like I was trying to make sense of e to the power 80. So e to the power a. So first way is what, 1 plus a square by 2 fact dot dot dot. This is a way of representing it using Taylor series, and it's a good way of doing this because this is the only way by which we can relate our this strange function with this thing, because what we know that we can multiply matrix and we can put matrix itself. Okay, so this is it. Now what I'm trying to say, like this is the way of finding e to the power a, it seems to be. So what I'm trying to say, what if I see it as a solution of a differential equation which we know, because when I was saying that solution was L, like x is c e to the power at. So what if I'm a fool kind of person? I put c as another matrix phi and a as this a, and a as function of t. Right? Like let me explain what I'm trying to say. That I'm a foolish person. I don't know what a matrix kind of thing is. I see this is a matrix and a x. So what I just simply does is what I simply think, like what I'm simply doing is that multiplying x inverse both sides from behind, this would vanish, and then multiplying a dt as a scalar both side. Okay, and I will compare from dx by x, it's ln x plus another vector c. Like I don't know what ln x is for a matrix. Like I know I would be even working upon it for like after some time. Minus c, I raise e's power, it's e to the power at into c. And what the solution we predicted for it was something a vector, or basically a group of vector. into e to the power a scalar t, like not a group of vectors here, specifically a vector, because then this would vary according to eigenvalues. Okay, so what I'm saying that a more good way of representing it is this, right? Our solution is this. So basically, what we will be doing to define it is that we will be making a differential equation related to this. For example, I want to find e to the power 1 2 1 1. So I'm making a differential equation like this, because the solution of this differential equation is in a layman's language, like considering a matrix as a scalar, is c e to the power 1 2 1. And being an educated person, like after seeing the above thing, the section 1, we know its solution is something kind of this, a group of vector kind of this thing, like c1, like not this, like this thing, right? A square matrix kind of thing. And c is something we will find in terms of initial values given, and if we multiply its inverse over that side, won't aren't we getting this thing? Basically the matrix we had made over there, v1 e to the power r1t, v2 e to the power r2t, where if we can even expand them, it's known as fundamental matrix phi of t, fundamental matrix. Okay, phi t. So basically here phi t is c times e to the power at, and if I multiply c inverse from behind, like from front, which is known any whatever my style, I'll say पीछे से आगे से, it's e to the power 80, right? And this is our intuitive way, and not intuitive, it's a standard way basically of defining it. And we have completed all our three objectives, and I don't like showing example of these things because examples take calculation and this spoils the fun of doing all these things. Okay, now what the thing I was saying that I'm trying for first time is basically trying to solve a random differential equation to define the functions. Okay, what I'm trying to say, let's say I want to define sign of a matrix, right? Like to define sign of the matrix, I even have one more way. I say it's e to the power iota a plus e to the power minus iota a by 2 iota, and it even makes sense, right? I can even write sin a like this, and let's just simply I'm now guessing, like I'm thinking a differential equation which I would like to solve in name of this. Why not simply x dash is 2x plus 3? However, this would be very simple kind of thing. Okay, basically this is our differential equation, and what the difference is here, that there in single variable calculus x is a variable. Now in our, I don't know what calculus is called, anyways, but this is something like this. These all are matrices. X dash is 2x plus 3i, right? This all is matrix. So there what were we doing? We were doing dx by 2x plus 3 is dt, and we integrated, we get ln of 2x plus 3 by 2 plus c is t, and 2t minus another c e to the power 2t k e to the power 2t minus, right? You understanding what I'm trying to say? But what to do here? Like here again I can do the similar thing, I was the stupidity I did over here, which helped us defining e to the power e. What stupidity? Like taking multiplying inverse both side kind of thing. X dash is 2x plus 3. However, you can scold me for this thing, but this is a kind of a stand form of kind of thing, right? X dash minus 2x is e. Okay, so viewer, what I'm doing that I'm just beating around the bush, just trying to find, like I'm just trying to generalize ways of differential equation in our simpler, in our matrix multiplication. Right now, integrating it, first of all, its derivative of x e to the power minus 2a is 3 times I e to the power minus 2a. These both are matrices, and I integrate over both sides. Integration of a matrix definitely means the same thing. Okay, like the matrix I will get integrating every element of function like we did in derivative. So integral of this is pretty simple, to the power minus 2a. Sorry, not 2a, just 2i. Oh, this is thing I've been missing from so long. It's 2i only. And what here? 2i. This whole is constant. So whatever the thing is, it's minus 2i plus into x, like x plus c. Where is ln? Have I done something wrong? Oh, sorry. Yes, yes, yes. I've done something wrong. Because it's not 2i, it's 2ix. It's minus 2x. So we want to be integrating it simply. It's basically integral of 3 e to the power minus 2x, right? Dx. Is it the same thing? Like this is it this? I really don't know. Like basically, I can say, I first of all let me explain what I'm trying to say. I don't know what language I speak. I'm saying that for matrix also, is it the same thing? And to prove, let's say, like to go for strange function matrix, just go on for series. This is my suggestion. Basically, its integral stands for the same thing that standing for that. So for that thing, what we need to prove that is integral of this thing. Is it the same thing over there? Uh, I don't know. The definition of this thing is that bus is its integral. Seriously, this thing. Uh, but I can prove its reverse, I guess. No, I don't know. I can even prove its reverse. Like it's is its derivative. This thing. Mm, into a dash. Yes, yes, yes. It's true. Why? Because a into a into a into a, all written like that. And if I take derivative, then using product rule, it's a n minus 1 into a dash into n, because it would be appearing n times. So it seems like I can write this thing over here. But yeah, there is one more thing like which I was missing, that we have to multiply a dash because we are taking derivative with respect to x. So where were we? Yeah, here were we. So basically integral of 3 e to the power minus 2a minus 2x dx. This is a very strange thing. Like seeing a change in a matrix with respect to a mix.